Now, repeating decimals in themselves are actually extremely inconvenient. If we encounter a repeating decimal, we often want to convert it back to a fraction. Now, there is a method for converting a repeating decimal to a fraction by hand. However, this requires more algebra than we have right now. On the other hand, our calculator can convert a repeating decimal to a fraction. Let's do some experiments to see how we can make this happen. Let's take as an example a repeating decimal that we already know about. We know that 0.3 repeating equals 1/3. Let's see what happens when we just enter 0.3 on the calculator and try to convert it to a fraction. Okay, that gives us 3/10. 0.3 really does equal 3/10, so that's not that surprising. What if we give it 2 3s? Well, that gives us 33 hundredths. Again, 0.33 really does equal 33 hundredths. Let's skip ahead a little bit. What if we give it 6 copies of the number 3? Oh, when we did that, the calculator just gave us the decimal back. The calculator didn't like 6 copies of the number 3 over a 1 followed by 6 zeros. 333,333 millionths. The calculator refuses to give us denominators that are too big. Depending on which version of the calculator you have, it might have been okay with this denominator and disliked a bigger one. The reason that the calculator refuses to give us denominators that are too big is partially because it's kind of guessing at really big denominators, partially because it doesn't want to give us something as a fraction that really isn't, and partially so that it can recognize repeating decimals. If we enter 12 copies of the number 3 and convert to a fraction, that actually gives us our 1/3. Now, with a longer pattern, you don't need to make 12 copies of the whole pattern. In fact, in any repeating decimal, we just need enough copies of the pattern to have at least 12 digits. So we might have the repeating decimal 0.72 repeating. On the calculator, we would enter 0.72, 72, 72, 72, 72, 72. Notice that this is 12 digits long. When we enter that, counting again on the screen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits. That was actually even more than I needed. That converts to be 8/11ths. Or if we have this decimal, 0.2567, where the pattern 567 repeats, on the calculator I'll enter 2, of course, and then copy the pattern 567 enough times, again, to get 12 digits. So 0.2, 567, 567, 567, 567. And I get that that's equal to 19/74ths. When you enter a repeating decimal on the calculator, include enough copies of the pattern to get up to 12 digits.